In this video, we'll be looking at Chapter 10, Section F on the sine rule. Now remember from the previous video that we studied the area of a triangle, ABC. And if we have this triangle with the angles written in capital letters and the sides, the opposite sides, written in lowercase letters, recall that the equation, or I can write three equations for the area of this triangle. One is 1/2 AB sine C, the other is 1/2 BC sine A, and the other is 1/2 AC sine B. Now these will all get me the same area, but notice how I have them written side by side and equal to each other. We quickly notice that the 1/2s can go away. Now if I decide to divide each of these expressions by A, B, C, I can further simplify each expression. In the first, I can get rid of the AB's, and I'm left with sine C over the length of side C. Likewise, in the second expression, I can get rid of the BC's, and I'm left with sine A over the length of side A. And the last one is sine of angle B over the length of side B. And what we've just written here is one of the most important identities in all of trigonometry, and this is the sine rule. Notice, if I know the length of one side and I know the opposite angle, and I know either another angle or another side, I can calculate the corresponding missing component. So in other words, if I know two sides in an angle, or two angles in a side of any triangle, not just a right triangle, I can find at least one of the missing sides or missing angles. It's important to note that the sine rule can also be written like this. And how you set up the sine rule when you're solving a problem can be beneficial. Both cases will work, but sometimes it's better to set up the sine rule using one or the other of these forms. Let's take a look at an example problem. In this example, we're given a triangle with certain information, and we're asked to find the length of side BC. Let's take a look at what we know. We know angle B is 41. We know angle A is 113, and we know side AC is 18 meters. Now I personally like to label the sides of my triangle so that they correspond to the angles. Remember that the opposite side should be the lowercase letter of the angle. So this side is side A, this side is side C, and this side is side B. So what we really know is angle A, angle B, and side B. And we're asked to find side A. Well, I'm relating angle A and side A and angle B and side B, so therefore I can use the sine rule. And in this case, I'm going to set it up as follows. B over sine of angle B equals side A over the sine of side A. Now in this case, I want to solve for side A, or lowercase a, so I'm going to multiply both sides of the equation by sine A. And now I have A equals sine A over sine B times side B. And now I can fill in the appropriate numbers. So I have the sine of 113 over the sine of 41 times 18. And this equals 25.26 meters. Now notice I put the unknown A in the numerator. I could have written this expression as sine B over B equals sine A over A, but the algebra is just a slight bit more difficult. So sometimes it's easier to put the unknown in the numerator so that I have to do less adjusting to the equation. In the previous example, we were asked to find the side of a triangle using the sine rule. And that's fairly straightforward. There's no ambiguous answer here. You get one answer when you're finding a side. When you're asked to find an angle using the sine rule, as we will be in this example, sometimes we can get two answers, and that arises from taking the inverse sine. And we've seen that in previous examples in this chapter. So when you're finding an angle using the sine rule, make sure to check for the second angle. And I'll show you how to do that in this example. So here we're asked to find the measure of angle C in a triangle ABC if we know side AC, side AB, and angle B. So let's draw our triangle here. And we know that B is an acute angle, so I'm going to put B here, and I'm going to put A here, and C here. And I know that angle B is 28 degrees. I know that side AC is 8 centimeters, and side AB is 12 centimeters. And again, I'm asked to find angle C. Remember to label the sides of your triangle. So this is side B, this is side C, and this is side A. Now we can set up our sine rule, and let's start with what we're trying to find, which is angle C. So I have the sine C over side C, and in this case I know side B and angle B, so I'm going to use B's here, sine B over side B. With a little bit of rearranging here, I get sine C equals C over B times sine of angle B. And now I can take the inverse sine of C over B times the sine of angle B is going to give me angle C. And now I can plug in my numbers. So I have the inverse sine of 12 over 8 times the sine of 28 equals 44.8 degrees. But remember, when we're finding the inverse sine, we have to find the second angle here. So C could also be 180 degrees minus 44.8, which equals 135.2. And so now I have two answers for this problem, which means I have two ways to draw the triangle above. C could be an acute angle of 44.8, or it could be an obtuse angle of 135.2. Let's take a look at how this situation arises. So let's begin to draw our triangle again. This time we're only going to draw side AB first, and then I'll start to draw side BC, but I'm going to leave it unfinished. Now we know that side AC is 8 centimeters. So what I can do is I can draw a line that's 8 centimeters from point A, and then I can draw an arc. Imagine I had a compass here of 8 centimeters. And so what I have, and I'm going to erase a line here, what I have are two lines that are both 8 centimeters long that intersect the side BC in two different places. Now this upper angle here is my smaller angle. I'm sorry, this is angle C. This is my smaller angle, which is 44.8. And here, this is my larger angle of 135.2. And you can see that in both cases the triangle is true. I have two triangles here, one in green and one in red. They both have side AB, which is 12 centimeters. They both have an angle B, which is 28 degrees. They both have a side AC, which is 8 centimeters, but they have different angles and different lengths of side BC. So this is the reason there are two answers when we take the inverse sine. We always get two answers between 0 degrees and 180 degrees for the inverse sine. And so in this particular problem, I don't really know enough to draw the exact triangle. It could be one of two triangles, and therefore I don't know the exact solution. Sometimes we can eliminate one of the two angles, and I'll show you that in the next example. Let's take a look at one more example. In this example, we're asked to find the measure of angle L in triangle KLM, given that we know angle K has a measure of 52 degrees, side LM is 158 meters, and side KM is 128 meters. So let's draw our triangle. And we can label it L, K, M. And again, let's label our sides with lowercase letters. And now let's fill in the information that we know. We know this angle is 52 degrees. We know side LM, which is really side K, equals 158 meters. And we know side KM, which is really side L, is 128 meters. And we're asked to find angle L. So let's set up our sine rule. Again, starting with our unknown, we want sine of L over side L equals the sine of K, because that's the other angle we know, over side K. Doing a little bit of rearranging, we see that sine L equals L over K times sine K. And again, I can take the inverse sine here of L over K sine K equals angle L. And so now I can plug in the numbers to find L. I'm going to take the inverse sine of 128 over 158 times the sine of 52, and that gets me an angle of 39.7 degrees. And remember, the second angle is 180 minus this 39.7, which equals 140.3 degrees. Now in this case, I can eliminate one of the answers. Take a look at the second angle here, 140.3, and then take a look at the original triangle. I know angle K is 52 degrees. Well, 52 degrees plus 140.3 is greater than 180 degrees. Well, I know that all three angles in a triangle have to add up to 180 degrees. It can't be more than 180 degrees. So therefore, this angle we can eliminate. And there's one true answer for angle L for this triangle. And now I know that this is the exact triangle I'm looking for. There's no ambiguity here. So always check your two angles and see if one of them can be eliminated because it doesn't fit with the other angles that were given.